So we're talking about medians today, and a median is the segment that connects a vertex to the midpoint of the opposite side. Okay, vertex to the midpoint of the opposite side. So in that picture box, draw yourself a triangle. Okay, make it, take up the whole thing, make it big enough so that we can see what's going on. But draw yourself a triangle. Doesn't matter what kind of triangle. Go ahead and find and mark the midpoints of each side. So eyeball it, right? Where would the midpoint of each side be? Put a little dot there. So we're connecting or we're drawing in the midpoints. And then what we're going to do is we're going to connect each vertex to the midpoint of the opposite side. So we're going through the figure. So from a vertex to the midpoint of the opposite side. So you're connecting across the triangle. And let's show on our picture that those are midpoints. Okay, let's put some tick marks in there. Let's show that these are midpoints. Okay, so we've got that picture drawn in where we are connecting the vertex to the opposite midpoint. Okay, it's important that we know that definition. We know what a median is. Median is always meant middle, right? So the median is the middle. We're connecting to the middle of the opposite side, the midpoint of the opposite side. Okay. So we look, they are concurrent, right? We see that. Those three should cross with each other. If yours is slightly off, that's okay. But it should be pretty close to looking like this. All right, so I've drawn in my median. Okay, I made it so that this will stay the midpoint. Whatever I do to the triangle, this is going to be the midpoint, midpoint, midpoint. I'm connecting. So I've got that point of concurrency in there. Let's take a look at what we can tell. Do you think that point can ever be outside of the figure?
No.
No, it's always going to be inside, right? Because we're always headed in to the figure. Right? So it's always going to be inside no matter what I do to this figure. Okay? All right, and I'm going to try to prove our point here. Help us with our theorem that we're going to look at. So here's our figure. Okay, we've got that point of concurrency there. That point of concurrency, of course, has a name. Let's name that. Put it on here for you. It is called the centroid. That is the coolest name out of all four of these. Centroid. Sounds like a transformer or something. So this is the centroid. So let's take a look at what we might be able to say about our centroid. Okay, and then we'll write down the theorem in a minute here. So we're going to look at this, and we know it's not a circumcenter, it's not an incenter, so those theorems aren't going to apply. It's not equidistant from our vertices, it's not equidistant from the sides. We can't say either of those things. What we're going to be able to say is we're going to look at the relationship between the distance from the vertex to the centroid and from the centroid to the midpoint. So we're looking at the relationship between this segment and this segment. Okay? We've got a graph on there. Can anybody tell? You should be able to see, since it's straight vertical, what the lengths are. What's the length from A to that centroid? What is it? 4. Okay, that's got a length of 4. How about the length here? 2. Okay, this is the relationship that we are always going to see with our centroid. Okay, it's always going to be 2/3 of the line and 1/3 of the line. Okay, 2/3 of the line, 1/3 line. And we'll put this in our theorem in a minute. Okay, we'll write it down. So whatever this is, you cut it in half, it's going to be this. If you know this, double it, and then it's going to be this. Okay, that relationship applies to all 3 of our medians. So however long this is, right, this is the midpoint to the centroid. Whatever distance this is, I'm going to double it, and that's going to be this distance. Okay, same thing here. Double this, it's going to give me there. So that relationship is going to exist every single time with our centroid and with our median. Let's put that in words. So we've got our centroid theorem here. There we go. There's our centroid theorem. Centroid is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Centroid is located 2/3 of the distance from a vertex to the midpoint of the opposite side. Okay. All right, so we're going to look at this figure, okay, because this is our general figure for centroid. And they're going to give us some information. They're going to ask some other things, right? Okay. So let's say that I know AD is equal to, let's say, 12. I want to know what AG and GD are going to be. I want you to think about that. Okay, so what do we think AG, GD are going to be? Yeah.
AG is A and GD is 12.
Okay, how did you get that?
Because, well, first, I don't know.
You don't know? It just magically came to you. All right. Anybody know why we can do this? Yeah.
Mr. Godowski, I have like
Yeah.
a way of telling. You
Okay.
do so AD is 12, you do 2/3 times 12. Whatever you get is the longer length.
Yeah, we can do that for sure. We take that 12, we know from our theorem, right? It's 2/3 is from the vertex to the midpoint, or 2/3 is from the vertex to the centroid. So if we take that total and we times it by 2/3, that's going to give us this length here. And then we can cut it in half to find that. The other way, maybe the easier way, so we don't have to use a calculator or do fractions, is if you just divide it by 3. If you divide it by 3, that's going to give you this, right? Because it's 2/3, 1/3. So you divide that by 3, you're going to get the smaller one, and then just double that, and we're going to get the bigger one. Okay. That's what most of your questions are going to look like. something about that, right? They're gonna give you some piece of information, you gotta solve for something else. Knowing that relationship, knowing that this is 1/3, this is 2/3, or knowing that this is half of that. Okay, as long as we have that relationship down, then we should be fine on these types of problems. Okay. Any questions so far with our centroid? Okay. Good deal. So the other type of question that we're going to see, and I told you yesterday that this was coming, we do have to look at the coordinate plane today. Okay, so we have to find the coordinates of the centroid for this. I told you yesterday that the in-center was the one that we weren't going to find it. So now we have to. So we're going to look at this problem. So we've got the vertices R, S, and T. So I'm going to sketch those out first. Okay, so we can get a visual on it. I got 2, 1. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5, 8, and then 5, 6, 7, 8, 3. All right, so I've got R, S, T. I've got that triangle here. I'll give you a second to copy that down if you're going to. All right, and then the last time we dealt with stuff in the coordinate plane, we were talking about circumcenter. And we said that they were always going to give you a horizontal or a vertical side so that we could easily find a perpendicular bisector. We don't have a horizontal or vertical side here, but there is going to be a centroid, or a median, rather. There's going to be a median that is straight vertical or straight horizontal. I might tell which median is going to be straight horizontal or straight vertical here. Hold.
The one that's going from RT, the midpoint of RT up to S.
Midpoint of RT up to S, because the midpoint of 2 and 8, right, is going to be 5. And that's where S is 5. So if I find that midpoint, that's going to give me a median that's going to be straight vertical. And we would want the midpoint to be straight vertical because then we can simply count rather than having to use distance formula. Right, so we can simply count once we know this midpoint, and this midpoint is going to be 5, 2, and this was 5, 8. Now we know the length of that median. We can apply our theorem to the 2/3, 1/3 thing. So if this whole
That
length
is awesome.
if we have this length of 6, right? Now we can apply that 1/3, 2/3. We know the distances need to be 4 and 2, right? When we split that up, 4 and 2. So if I go 4 down and 2 up, right? I find that point. That's going to give me that point 5, 4. That's my centroid. I don't even have to worry about drawing in another median. Right? All I have to worry about is one median and being able to do that 2/3, 1/3. So it's slightly easier than finding the circumcenter. Okay, because we don't have to do the equation. Okay. Questions on that?
That is so much easier than circumcenter.
A lot easier. A lot easier than circumcenter. Caleb?
My drawing doesn't line up like
So you're going to have to just be careful of how your spacing is, right? And just making sure that you're trying to get even spacing there, because chances are if it doesn't line up like that, it's your graph's just off. Human error. Yeah. All right, so we said this is easier than circumcenter. If you guys are okay with it, I'll show you an even easier way.
No.
No, you don't want an easier way?
Yes, an easier way.
All right, okay, so here's what I want you to do. I want you to look at the three x values of R, S, and T. The three x values of R, S, and T. Okay, and I want you to look at the x value of our centroid. Okay, our centroid was 5,4. Now I want you to look at the y values of R, S, and T, and the y value of the centroid. And I want you to think, how can I get from those x values of the centroid to the x value, or x values of the vertices to the x value of the centroid?
That's pretty cool.
Yeah.
Add the 1 and the 3 together and then minus the 28.
Not quite. Good idea, that is true, but that's not the pattern that we're looking for. Hold.
Just take the average.
Take the average. Take the average. Add them up, divide by 3. You add up your x's, 2, 5, and 8. That's going to give you 15. Cut it by 3. That gets you 5. 1 plus 8 plus 3 gives us 12. Divide by 3 gives us 4. The centroid is the average of the x's, the average of the y's. It's sort of like our midpoint, right? Only we're dealing with 3 points here. So it's the average of the x's, average of the y's. Add them up, divide by 3. We don't even have to worry about the graph then.
We don't need a new graph.
What's up?
We don't even have to graph for this one.
You don't even have to graph it, right?
Why did you do that the first time?
So you would appreciate this a little bit more?
I think you said that.
I have. I do that often. But it does. It makes you appreciate the shortcut a little bit more, right? A little bit nicer now. Not that this was difficult, right? But the average of the x is average of the y is a little bit easier. Right? Average of the x is average of the y for the centroid. That should be a pretty easy one to do. Okay? Right. Any questions on that? Okay. So one more thing, and then we're going to look at a word problem, and we'll call it good for today. The last thing that we got to put on there under other information, the centroid is considered the center of gravity or the balance point of the triangle. Sometimes you'll see this in word problems. They'll talk about find the center of gravity or find the balance point here. What that means is, let's say that somebody gives you a wooden triangle, big wooden triangle. And they said, I will give you $100 if you can balance this triangle on your finger first try. All you would have to do is find the centroid, and that's where it's going to balance. Okay, that's the balance point. The center of gravity is that centroid of that triangle. Okay? Not that anybody's ever going to do that to you, right?
Wait, what was the other thing that we were talking about? That like it was like a sport, and we were like, oh, you can win the sport if you whip out your
think it was
map.
Oh, cool. Yeah, cool. If you do the reflections, right, and bounce it off, yeah. All real world things, right? All things that could happen to you. You don't know. All right. So just be aware of that. If you see that in a word problem, that's what we're talking about. Okay, we're talking about centroid for that. All right. So let's look at a problem on the book here. And this is just making sure we understand that relationship. So we'll talk about these 3, and then we're going to be done. So they're giving you 3 different situations here. Okay, so do one at a time and solve for those 2 that they're asking for. Go ahead. Be careful because they're not all talking about the centroid, right? They're talking about different parts of the triangle too. So just be careful what they're actually asking for here. Another minute or so, and then we'll talk about it. All right, so let's look at number one. Number one tells us that SC is 2,100 feet. Okay, so that's a median. SC is 2,100 feet. What's the length of PS and PC? Okay,
PS is 700 and PC is 1400.
good. So again, that's the 2,100 divided by 3 gives us the shorter one. Double it, we get the bigger one. Okay. Now the next one says BT is 1,000. So now we're looking at on the edge of the triangle. We want to know what TC and BC are. Both
1,000 and 2,000.
1,000, 2,000, right? Because this is a centroid, that means these have to be, our T has to be the midpoint. So those have to be congruent, good? So 1,000, 2,000. Now we're saying PT is 800. We're saying this is 800, and we want PA and TA for this.
P is 1600 and P is 2000.
There you go. We know this is half of this, right? 1/3, 2/3. So this is 1,600. Add them together. TA would be 2,400. Good. Any questions on that or on centroid?